So, what kind of computer ran the first web server? Anyone? Oh, I heard a next cube from over here. That is the correct answer. Give the man a round of applause while he gets his mouse pad and t-shirt. So, question number 2 for a book on PCI compliance from Singress. What Outlook macrovirus was the first to infect 1 million computers? I'm sorry, it says Melissa, but the person that said Outlook. Yeah, I'm giving it to the guy that said Outlook. I think that was... He's not coming forward, so Melissa can have it. So, are the AV folks ready in the back? Are there AV folks in the back? Hey, there aren't any AV folks in the back. We'll deal with that. So, now I present to you Michael Weigand. He is going to give you, a talk on building your own Predator UAV. Give him a round of applause.
Good afternoon, Shmoocon. Is my mic working? Everybody hear me? Awesome. All right, so today, again, building your own Predator UAV at 99.95% discount. Before we really get started with the presentation, I just want to give you a little demo. Just yesterday, we took the plane out in front of the hotel. Bellhop gave us a really strange look. And we put it up about 2 hours after the snow started falling. So let's see if we can show you the video we hashed together.
Target head and to the left. Target on site. Sticking around. Rear service entrance.
So you can see the hotel right there. We're kind of going around to the back.
Let's get a look down.
I personally wanted to get a shot of Bruce in his snowshoes, trekking around outside, but I don't know if we caught him or not.
Weather front. Interference. Alright, snow's starting to look heavy now. Let's roll out. Off target, off target.
So the RF link admittedly was absolutely terrible. I don't know about you guys, but I couldn't really tell what was going on. I blame that entirely on the snow and all the embassies with their jammers in the area because I have never seen anything so bad in my life before. It's a really quick, I got to give the standard disclaimer. I am a cadet at the United States Military Academy, which means I'm 21. I don't really know a lot. I'm just a student. So I have to give this disclaimer that anything I say or do up here doesn't represent the Army, DoD, West Point. All this information used at your own risk. Just like anything, it can be used for profit or gain or for some pretty terrible things if you put your mind to it. So don't come looking at me afterwards. Okay, everybody's seen the MQ-9 Reaper or the Predator drone. This is a picture I found on the internet of it in some sandy environment. Unfortunately, the title of the talk is a little misleading. This is the actual plane up here today that I'm going to show you how to make, and it's not quite a Predator, I'm sorry. It doesn't have the cool missiles on the bottom, and it doesn't fly for 20 hours, but yeah. That's right. I haven't installed them for this demo because that would look a little sketch, but you can do what you like. So real quick introduction to UAVs and autonomous technology. Autonomous basically essentially means a self-governing. It's a robot that makes its own decisions. It's independent of human interaction. The best thing about autonomous systems is that when applied to aerial vehicles, we actually have taken the technology pretty far so far. With ground robots, you have to take into consideration the environment and sensing, obstacle avoidance, and all this other jazz. And when we put a plane up in the sky, we know we got to deal with with the fluid that it's coming through the air. The weather obviously can be a problem like we found out yesterday. But it's actually a lot easier to make autonomous or semi-autonomous vehicles when we're dealing with airspace instead of ground space, or in some cases sea space. So a lot of the autonomous technologies that we see out there, all the advanced stuff has been created predominantly for aerial systems. Now, some of this has matriculated down to the hobbyist level where my budget kind of comes into play. And so I'm going to kind of demonstrate where the current status of this technology is, how you can go out, assemble the parts, and put a pretty cool system together and apply it for your own needs. So the marketplace, just a quick overview of where UAV systems fall, especially when you want to go out and buy your own autopilot and put it in a model. In the red box you see up there, these are commercial vendors, Micropilot, Proctorus, UNAV, CloudCap. They sell basically ready-made autopilot systems that you can integrate in anything from a Cessna to a little tiny, hobby foam plane like I have in front of me here. These systems can range in cost anywhere from $1,000 to $30,000. And if you pay these guys enough money, they'll basically make anything happen. Unfortunately, like I mentioned, I'm just here on a student salary, so I'm more interested in the free, open source, extremely inexpensive systems, which is probably what you guys came to hear about as well. Starting at the very bottom, the ArduPilot is the system that I base my drone on here, and that I'm going to talk about for the remainder of the talk. But there's also some great other projects out there. The UDEV board, Paparazzi, these systems have been around for a long time, especially Paparazzi. It's based on I'm not even going to actually attempt to speak on it because I'm not too familiar with it. But it's been out there for a number of years, and it's been developed for several different airframes and utilized successfully. If you guys want to check out some of the other systems, I'd highly suggest you reference this slide. Just Google these keywords, and there's a wealth of information out there. So UAV essentials. Obviously, the first thing we want our UAV to do is to simply fly, to get up into the air and stay up there. This requires the plane itself to inherently have some stabilization and to be able to take care of itself when a gust of wind kind of tips it on its side or whatnot. And also to maintain, thrust and lift greater than, drag and weight. I threw the little physics block diagram up there in case there are any scientists in the crowd to kind of give a free body diagram of how a plane moves through the air. But essentially what we care about is making sure that the plane stays up in the sky. Once we have that problem solved, then we can deal with navigation. Where's the plane going to go? And this really isn't that complex a problem, especially when we have GPS sensors, IMUs, and other devices that can give us a relatively precise location on the planet. And then, obviously, our third task is dealing with our operating payload. The whole reason we put the UAV up in the sky is so that it could carry something to do something useful, usually sensing, sniffing, transmitting. On the plane I have in front of me, and I'll show a blow-up picture for those of you who can't see, I simply just have a camera on. That's what we flew with yesterday. Obviously, that camera feed looked pretty bad, but that was the RF link. But it would be all too easy for somebody to create a wireless sniffer. War flying has been done before, and those payloads can very easily be carried by this airframe here, or one that you could engineer. Transmitting signals would be very easy to do. You can even mount lasers on pan-tilt gyros on the bottom of these sensors, in a very small package, and basically do whatever you like. So that's pretty cool. All right, stabilization. So wings level, please. There's two basic systems that are going to allow us to keep our plane up in the air, flying wings level, and relatively carefree. The cheapest, easiest solution is based on infrared sensors called thermopiles. As you can see there, they're really small. I don't know if any of you guys can see, but at the very top of the plane here, I have this black box. That black box right there just has 4 sensors on it that just read the infrared differential between the sky and the ground. I'll talk about that next slide. The second system that really aids us is an inertial measurement unit. Now, these are a little bit more expensive, in the $100 to $200 range. And they're not that accurate right now. They're susceptible to drift over time. Essentially, they're just a mix of gyroscopes and MEMS accelerometers that are going to allow us to detect the different forces upon the plane. That, coupled with GPS and thrown in some control algorithms, actually gives us a very accurate idea of what's happening to the plane. And then we can adjust, making servo corrections. So depending on how complex you want your system to go, you'll either go with the infrared sensors or with the inertial measurement unit. So the thermopile-based approach. In the upper right, you see the FMA Direct Copilot. This is the main sensor. This is the one I'm using here. I think it goes for about $50, $40. It's very inexpensive. All it does, as you can see the picture on the left with the fighter jet, is it has these windows, these little thermopile devices on 2 axes, and it detects the thermal differential between the sky and the ground. When we go outside, even on a day like today, where the ground's covered in snow and ice, the ground is still going to have a warmer heat signature than the sky or than space. And so because we get a nice little bell curve, like you can see in the lower right-hand corner, we can take these values in, and then just using a microcontroller and a very simple algorithm, we can then send out signals to our servos, which will move our control surfaces and level the plane out. This device right here will level us out in 2 axes, going like this and like this. So I can't remember the names. I think it's like pitch and something, but whatever. We'll deal with that later. So servos. Servos are kind of an important thing to know with a plane, because these are the mechanisms that move the control surfaces. Many of you may be familiar with these. Don't think I was supposed to say that. But essentially, it's just a motor, control circuit, and potentiometer. And they're controlled by sending out a pulse width modulated signal every 2 milliseconds. And you can just rotate the arm, usually about 180 degrees from left to right, or 90 degrees. Some models are continuous rotating, like on the Parallax robots, where they actually use the servos just to turn wheels and drive robots around. We use these to make very precise movements to the control surfaces, like the ailerons, the elevators, the rudders on a plane. And this is what's essentially going to allow us control over our airframe. So now, the brains of the operation, the ArduPilot. This is the $25 autopilot that made a bit of a splash on the scene about 1.5 years, 2 years ago. It's based around the popular ArduPilot microcontroller and was created by a guy named Jordi Munoz. Jordi Munoz met the Wired editor-in-chief Chris Anderson, and together they kind of built a community called DIYdrones.com. Now this community is the place to go if you're interested in UAVs. Let me caveat that. If you're interested in making your own UAV. These guys are the ones who like to know everything from soup to nuts, and they build their own systems from the ground up. Their focus is on inexpensive systems, and everything that they publish is open source and open hardware, so they're a great reference. I highly recommend you guys check that website out if you're interested. So the ArduPilot, about 1 year ago, they released a shield, which, if you guys are familiar with Arduinos, shields are just circuit boards that just snap on top of the base board. The ArduPilot shield brings a couple more systems to play in an easy, integrated, and very small fashion. Here you can see that black box with the 2 nozzles coming out. That is a differential pressure sensor. And when we connect a rubber hose to a tube out front, we can measure airspeed. This also has some circuitry that allows us to update the code on the microcontroller without having to unplug the GPS, since they both share a single serial line, which is a disadvantage I'll talk about how the community is overcoming now. But anyways, when you mount the shield on top of the ArduPilot board, you essentially have all the basic components that you need for a fully integrated autopilot system. Now, ArduPilot's gone through a couple different generations. They're currently on generation 2.5, or version 2.5 of their code. And the system overview has changed slightly. Initially, they were using the FMA Copilot system to provide stabilization totally separate from the ArduPilot. But now, with the shield, you can actually connect the thermopile systems directly in to the shield board, which communicates with the ArduPilot, and the ArduPilot makes all the calculations for us. So we take that third-party application out of the picture. As you can see here, though, I just want to point out, we have a RC receiver on here. This isn't a completely autonomous system. I guess the best way to put it is semi-autonomous. Takeoff and landing still has to be done manually at the moment. This is a problem that the community is working on. But it's also important for FAA legal issues that we be able to take control of the plane, safety's sake. Let's say yesterday I was flying the plane and it starts to head on over to the vice president's house. I'm probably going to want to flip a switch and bring it back before I get arrested. So that's a key component I just want to point out. But anyways, its received signals just dump right into the ArduPilot, which then connects straight to the servos, to the electronic speed controller in the bottom right, which is essentially our throttle. This gives us filtered power for all our devices, connects the battery and also also connects to the motor, which is going to be our main thrust source, obviously. In the shield, of course, the GPS plugs into that, and we have our sensors. So right here, these are all the systems that you need, essentially, to have a complete semi-autonomous autopilot system. So when the entire system is integrated onto the airframe, it looks something like this. Now, the GPS system that I'm using, I keep internal because I kind of upgraded the GPS model. This picture here is about 6 months old, and these guys keep coming up with new updates, probably on a 2 to 3 month basis. But as you can see in the front, kind of hole right there, you have the autopilot with the shield and everything plugging into that mess of wires. The battery also is going to be located up front. There's a lot of space up there. You see the Z sensor on the side. This is just thermopiles looking up and down. This gives us better calibration data for the X and the Y sensor, which is on top. And then we have our GPS, which we just kind of keep out of the way and with a clear view of the sky. That black box in the middle side there is the servo, and that connects to a control wire, which will move either the aileron or, either the elevator or the rudder for control. In the front, like I mentioned earlier, the pitot tube, essentially we just have a metal tube that's sticking out of the foam somewhere, and it's connected to a little hose and goes to that differential pressure sensor. So this is just going to direct the airstream to the sensor so we can see how fast we're going. I mounted it on the side. I don't know if you guys in the back can see, but I like to put it back here, kind of more resembling a normal pitot tube setup that you would see on a regular aircraft. But really anything works. You can just kind of push it through the foam up front. Too easy. An awesome creation by the DIY drones community is the Autopilot config tool. This is a little software script, or I guess an application that was written by the community that allows you to just pull up a Google Maps interface and then just drop waypoints where you want the plane to fly. Really awesome features of this include Google Maps supplying us the data of the ground, the ground level wherever we happen to be at, and then you can specify how much higher you want the plane to be. Some members of the community noticed initially when they were using just GPS coordinates that their planes would kind of fly into the side of mountains, and so this was an issue. They quickly rewrote the code to kind of include this, but this was for this specific setup where you see this bow tie pattern here. The community has, I think every 2 months they throw out a new contest where you can go on there and you look at the rules and everything. In this case, you had to fly a certain pattern. I think it was a 300 or 200 meter square cube that you had to fly in a certain orientation, and then you film the entire thing and you send all your telemetry data and everything off to the website, and they, in this case, it was a time trial, so the person that got their UAV around this the fastest won. Cool thing was you could submit it using any plane and any system as long as it was kind of within our category. Obviously, I think the Air Force was excluded because they would have won. I think the winner, I want to say he did it in less than a minute. Yeah, this thing was, he punched the throttle up and it's flying all over the sky. Probably crashed afterwards, I don't know. I didn't make the top 10 list, so anybody that was ahead of me, whatever. Yeah. I was happy that it actually made it around. I was like, oh, sweet, this worked. And then it kind of flew into the side of a building, and that was the day. Yeah. So telemetry, I mentioned the data that you need to get back down to the ground. Zigbee radios really are ideal for this purpose. These things are tiny. They're only a couple credit cards thick. It's just a simple board. Here you see the two that I use. The one on top is my ground station one. I have that. I use the RPSMA models because I can attach any antenna I want to them. And it has a SparkFun breakout board on the bottom, which gives me really easy USB connectivity to my computer. So I just run a serial monitor on my computer and just save all the data. The one on the bottom is using a breakout board from LadyAda.com, which gives us the pinouts. And we just push serial data directly from the microcontroller right to that. And you can get that seamless serial link. If you use the right models and the right antennas, you can get about a 12-mile range out of these things. The range is kind of decreased a bit by whatever your video setup happens to be if you don't have good filtering and everything. We'll talk about that when we get to RF. So I actually came up with the idea that, oh, there goes the shot glass. All right. I actually put the antenna back in here. The nice thing about these foam planes is that you can cut them up. So this plane splits in half. I'll show you in a couple pictures. And I mounted the antenna in the rear boom here, which keeps it nice and separated from the video transmitter up here. It's kind of the best you can do. So when you do that, you get a little bit better range, but you really want to make sure that none of your RF systems conflict with each other. The video feed. I guess I'm really not qualified to talk about this because my video sucked, but I'll show you some better ones. Maybe I can get some faith back. Board cameras are the way to go as far as your actual camera setup. They're very inexpensive. The one I'm flying here is actually only $18 online. I probably could have spent twice as much, forfeited a meal or something, but whatever, it worked. So board cameras, the best place to get them I found is from supercircuits.com. You can find them anywhere from like $200 down to, I think their cheapest model's like $5 or $6. I don't think you'll get amazing quality out of that one, but usually in the $30 to $60 range, you can get really awesome color board cameras that are very lightweight. Obviously, if you lose it, it's not really a big deal if it messes up. Transmitters is more of a problem with these setups. I really want to stress you have to really have a ham radio license to do anything in the RF bands legally. The regular civilian bands that are opened up, if you don't have an FCC license, kind of stink for video feeds because anybody and their grandmother can have like a little security camera outside and it be transmitting wirelessly, and that's really going to mess up your video feed, especially when you go 3 miles over the hill and you're checking out that X that you kind of never got over. So, as one of my friends says, it's not stalking if you love them. So. But 900 megahertz is probably the best frequency range for this kind of setup if you just want to buy something off the shelf. Rangevideo.com has a $50 transmitter, and then you can buy like a $30 or $40 receiver if you just want a system that you plug and go. And you need a ham radio license to operate that as well, unfortunately. But if you want to roll your own system, I want to recommend the 434 megahertz or 1.25 gigahertz ham radio TV bands. These things are awesome, and you can probably push video, I'm going to guesstimate, well out over 10 miles. The ham radio guys usually send video a couple hundred miles on a regular basis. They'll do like a web chat or whatnot. So if you can just find a way to miniaturize that equipment, which shouldn't be too difficult, keep it in a lightweight package, then you can easily integrate this into your plane. But in the upper right, that is the video setup I'm using. So you can see that the transmitter actually is only a little bit larger than a standard composite jack, so you get a feel for how small it is. And the video camera on the upper left-hand corner, I kind of blew that picture up. I don't know if you can see it. This thing's tiny. It's right here. I mean, this would easily fit in the palm of my hand. And I'm pretty happy with it. It survived a bunch of crashes. And again, at $20, it's disposable. GPS. So GPS obviously has revolutionized our way of doing things. None of us can read a map anymore, which I guess is good. You don't have to carry that around. But for UAV systems, this is a must-have system. You have got to have a GPS receiver because it's the best way to get positional data. So the systems, the components that you want to look for are going to have a very high update rate or refresh rate, and obviously you want them to be accurate. The GPS component on the left there is a U-Blox chipset mounted on a helix antenna, and this will give you a 4 or 5 hertz refresh update rate. The one on the right is the one that the ArduPilot system was originally based on. They've moved away from this because it only updated positional data about once a second. But these two, I think the one on the left can receive up to 50 channels, the one on the right up to 20 channels. And ideally, you're looking at positional data from anywhere from ½ a meter if you're having a really good day to about 2 meters on average. So, that's all you really need for these UAV systems up in the air. Now, the airframe. This is the best part, I think, because you really get to pick whatever you want to put this guy in. I've seen model airplanes that look like, quite literally and on purpose, flying lawnmowers. I don't know if you can actually modify these to, to wear or to, fly autonomously because they're not going to have capabilities you want. But you really can take most foam models and modify them with this setup. Foam is the best. You don't want to go with that old balsa stuff wrapped in shrink wrap and everything, because anytime you hit something, it's going to fall apart and you're going to be crying on your knees. So yesterday when we actually put this up, we flew into a tree to land it. I swear that was intentional, okay? Again, all the cabbies kind of came out and they were staring at us and buzzed them real quick. The plane's coming in too low. We take it around again. Oh, there's a good tree. I'll just land it into that. So foam is the way to go because you can easily fix it. Gorilla Glue, this is a secret, just between me and you. Gorilla Glue, mix a little bit of water, it foams up. Now this stuff is beautiful because if this plane snaps in half, I can have this ready to go the next day. In fact, I've done this on multiple occasions. The plane literally snaps in half because I did something stupid, like I stepped on it. And a little bit of Gorilla Glue later, yeah, you can see the little seam, and you're like, wow, man, this thing looks like Frankenstein right now, but it flies. So, also, foam's really easy to work with. Obviously, you can just cut it out pretty simply, and you can tape it together. So, the best thing about this plane right here is, if you guys actually come up afterwards, I can show you. The entire thing's held together with Scotch tape. I swear. There's not an ounce of there's no bolt. There's no tape or no glue, and the whole thing's just Scotch taped together. And then I use a little bit of packing tape along the leading edges and to keep the wings snapped in. Works beautifully because, I'm a prototyper, so as soon as I'm done with this, I'm going to tear it apart and try a new payload, try a new setup. Tape's the easiest way to go. You just cut it and pull it off next. So the airframe of choice, ladies and gentlemen, this is the Multiplex Easy Star. This is the plane that you want to have, or at least the kind of the genre of plane you want to have if you're going to roll your own system. Essentially what you have is a pusher motor setup, so we keep the prop to the rear and high of the wing, so we don't have to worry about how this thing's going to land. We don't have to worry about the extra weight of landing gear because it's just going to slide on the ground or smack into the side of a building for recovery. Very effective method, I might add. And remember, foam doesn't really break easily, so as long as your electronics are cushioned, that actually is a recovery technique. I have demonstrated this. The plane is it's perfectly recoverable. It kind of, it gets a little smushed up front, but whatever. So anyways, this is a really nice system because you'll also notice how the wings are kind of bowed up at the tips. This gives it some stability without having to use any electronics in the first place. So it natively wants to kind of keep wings level. It doesn't fly upside down whatsoever. I tried that. It crashed. So anyways, and the best part is that it has a huge payload area. Where you see that black canopy right there, you can just pull that off and throw as much electronics and batteries in it as you want. This, also because of the airfoil, you can really pack a lot of weight on as well. I think my model weighs something like 2 or 3 times as much as the kit is supposed to weigh, and it works fine. I've packed actually about 2 pounds of payload in this thing and somehow made it fly. So there you go. This is what it looks like when you pull it out of the box. It's not going to have anything installed, and it splits right down the middle, which makes it really easy to kind of mount your components. And so the first thing that I do is install the propulsion system. Motors are kind of a big deal with these because obviously it's your only way of getting them up in the air, and you're not really going to use some type of nitro-based or gas-based model airplane engine because they're just kind of big, and I want mine to be quiet. I want this thing overhead at 200 feet, and you're not even going to know it's there because you can't hear it, and you can't see it when it's white and it's up against the clouds and everything. So, anyways, the stock motor that comes with it, it's actually pretty weak. It's more than enough for the plane when you're just playing with it, but when we're carrying all these extra batteries and all this extra payload, we want something a little stronger. So in model airplane, circles, the best way to go when you want to upgrade any type of electric motor system is to go with a brushless system. This is what I have here. If you go to the DIY Drones, website, they've gone out there and they've tried all the different motor setups, and they have concluded that, as market currently states, this is the best one for this airframe. That's a $50 brushless motor. that'll turn at several thousand RPM and will take your finger off if you're not careful. We're using a PVC prop, and I have an ESC, electronic speed controller. That's that kind of box that all the wires are going into and out of. You want to upgrade the ESC to something that has a little bit more, it can handle more amps than the stock system, although I think you can use the stock system with this. It might not be good for the motor because brushless and brush motors use different speed controllers. But you just wire this together. Maybe you're going to have to cut out a little bit more foam to fit this guy in there. The wire's a little bit thick, but we just kind of place it in there, make some incisions. You see there's kind of a hole up towards the front. There's another servo cable coming out. The servos are literally just pushed in the side, and I hold them in place with tape on the outside. And those go to our control rods. So now here I've stuck the receiver in. And at this point, the plane is actually a fully functional remote control model airplane. We've got the receiver that's plugging into the ESC and into the two servos on the outside of the plane. So this guy can fly under manual control.
Can you tell me what brand that brushless motor is?
The brushless motor is from, I want to say Hymax. It's a Hymax. I can't remember the exact model number. If you go on the DIY Drones website, they have it all. They've got it all there. And this is what the finished system looks like. Unfortunately, my camera kind of broke, so I couldn't take any pictures integrating the autopilot, but we have everything under that front hood there. And you can see the antenna coming out for the video transmitter. So you literally just plug everything in, just like we had the systems diagram, as I showed you earlier, and it's ready to fly. So, the payload, okay. So like I mentioned, that board camera, this is my $18 board camera. A pan tilt system is going to allow you to kind of slew this and target it independently of the aircraft's movement. So obviously, the way that you want to fly this, if you want to kind of be a badass, is to get this guy up there. You give it its different waypoints. It just goes up there, it's flying its route, and then you can take control of the camera. So the coolest way to take control of the camera, if I may borrow from my military roots here, is to mount a gyroscope inside your good old bike helmet. You put this guy on top, right? And of course, we're safety-conscious people, so we're going to snap this in. All right? And this is going to attach this gyroscope. I didn't put it in the slide. If you search head mount gyro, you'll get it. I think it's called a R2 head tracker. But anyways, this guy's going to attach to your RC transmitter. And then you can don your super awesome video goggles like this. Okay. I know, I look like somebody out of Star Wars right now, don't I? But then all you need to do is just to press a switch on your video transmitter, and then however you move your head is going to slew the camera in 2 axes. Now, I didn't come up with that system. The only kind of contribution I made to the community was the idea of mounting it under the wing instead of right here. Usually they won't put this foam canopy on and they'll have the camera up top. But I thought, man, that's not cool. I can't look underneath the plane. And what if my target goes behind the plane? Then I got to turn the whole thing around, kind of put the nose down. Eventually I'm going to hit something. So if you mount the camera underneath using these micro servos, which you can get from any model airplane store, and a $20 pan tilt system. It's literally just a couple gears, as you can see there. Then you can slew this camera, almost 180 degrees behind you and to the left and whatnot. So let's see. Oh, movie time. All right. So what you're going to get when you incorporate that entire video system there. Oh, looking at the grass, upside down, grass. Man, this is bad. Okay. Because it's going to look something like this. Yep, it works. Okay, we can take off now. I was getting a little nervous every time I put this up there because, this is like a month's pay. We're going to take off. There we go. All right, so we're airborne. So when you fly this thing, the first thing you want to do is just get up to altitude. Model airplane guys call this 2 mistakes altitude. For me, I'm not really too quick on the stick, so I guess it's like 1, maybe 1.5. But you get it up there, and then you literally just flip a switch. The autopilot system currently has 3 modes. Manual, it has autopilot, and it's just going to fly its route, and then RTL, which stands for return to launch. So here we're kind of slewing the camera a little bit. As you can see, the video resolution is pretty good. You can see people walking on the sidewalk there, right below us. Yeah, it was really windy that day that we took this video, so that's why we're kind of shaking all over the place going downwind. But as we make a left-hand turn here in about a second, we'll really stabilize out. And at this point, we are completely hands-free. We're just checking out the video feed, sipping a Long Island, and sitting back. So let me see if I can get to the interesting parts. We got bored just kind of flying around after a while, and we decided, let's see if we can follow people. So turns out it was a little too windy to get like really low and kind of freak them out. You can sneak up on people from behind. I'm telling you, this thing's great. But we, oh, damn you, Vista. There we go. Where did we start following the bus? Yeah. Buses, where are you? Here we go. Nope. Apologize, my video editing skills were like terrible. I eventually gave up trying to work Vegas Pro. Oh, we got a question.
What's the legality? Can you just fly anywhere without any permit, or are there any restrictions on how much you can fly these things?
So, I think you're not allowed to fly in like restricted zones. If any of you are private pilots, you might be able to answer this question better. But I think
So how are you able to fly in DC then?
in DC. No. We'll talk about legal issues. We're dealing with model airplane rules here. But basically, as the rule of thumb, I think if you wouldn't fly a Cessna over it, you probably shouldn't be flying this over it, especially when it's transmitting back to you and they can kind of, direction find your position, because that wouldn't be good. Stall speed depends on how much payload you stick in the plane, but I think you're looking about 20 miles an hour. When you really crank it, you can do 60, maybe 70 miles an hour on this plane. Yes?
Couple of questions. What's your hull weight? How big's your battery? And how long is your flight time?
Very good question. I should have put this in a slide. So lithium polymer batteries have kind of made news recently because they're being used to power all the electric cars that Detroit is still trying to figure out. And I didn't think it was that hard. But what you want to do is you want to go out. There's a website called, Hobby King, hobbyking.com. The Chinese right now are making the best lithium polymer hobby cells. And for $20 or $30, you can get all the way up to like a 4,000 milliamp hour LiPo battery. That's going to be about as long as a Hallmark card and maybe about a ½ inch thick. It's going to weigh a bit depending on how much energy density you have. Or I'm sorry, they all have the same energy density, but depending on the rating of the battery. Right here, I'm flying with a 1,500 milliamp hour battery, and with that, I can keep the plane up in the air for about 45 minutes. If I want to put a larger battery up, obviously kind of got to keep your throttle up a little higher to keep the plane up. But the best system I have right now, I can keep this plane airborne if I'm just kind of loitering around and not doing anything high speed or crazy for over an hour. So you're looking about an hour 15 minutes. Honestly, after about 20 minutes, your neck kind of gets a creak, and you're like, man, it's cold out. I'm going inside. So that's kind of the battery situation. It really is up to you, but LiPo batteries are the way to go. Forget, NiCads and nickel metal hydrate batteries. Yes, sir.
Michael, if the plane goes down, are the radios on board enough to find it?
Yeah, so, this thing doesn't stop transmitting when it hits a building. So. Oh, yeah, you got video. You're going to have a lot of interference and everything, as we found out when we hit a tree yesterday. Like, oh, that looked pretty gnarly just from the video feed. But well, yeah. So if you're using the telemetry, the autopilot system is sending its GPS coordinate to the ground station as soon as it gets it and processes that information. It's also sending other information like airspeed, heading, next waypoint, And you can configure it however you like. The best thing about ArduPilot is it's open source, open hardware. So, I mean, I'm sure you guys could do more with it than I can. But yeah, if the plane goes down, you have its last position data, and as long as it hit the ground, it isn't currently moving, then you could probably go get it. The worst thing is when something kind of flips out and it just keeps flying. Because at some point, it's just going to like fly over the horizon, and you're going to be like, oh man, I don't have enough gas money to go get that. So, yes?
Two questions. One, what's your total payload? How much can you actually lift with this?
I haven't actually calculated it out, and I'm really not qualified to answer that. But if I had to give a rule of thumb, I'd say probably you could probably get a ½ pound up, but usually you're talking ounces, like 6 ounces is ideal. But actually, I don't know, you might be able to do more. It all depends on the airframe and what you're comfortable with.
Also, did you have to counterbalance for the, maybe you mentioned earlier, did you have to counterbalance for
Yes. A funny story about that, guys. So, if anything, thank you. If anybody knows anything about airplanes, then you know that you have to, you got to keep them balanced. And if they're not balanced, then they don't really tend to fly very well. One day I was messing around and I had a really heavy payload and I just kind of popped that out and I didn't rebalance the plane. You have to find its center of gravity and make sure that everything orients around that. And with any model airplane or any plane, they'll tell you where the center of gravity is supposed to be in relation to the wings and to the fuselage, and you have to keep the plane balanced within those bounds. So I didn't do that one day. I put the plane up, and I was like, man, this thing's flying really funny. Anyways, when we came down to land, it stalled out and then just did a nosedive from about 60 feet up. So that was the end of that. That was the end of that model. But you know, the best thing about foam is, you know, you can just take all the electronics out, put it in another foam fuselage. I didn't put prices on the slides intentionally because a lot of this stuff depends on your own setup and how you want to do this. But the foam model here, if you don't buy it with all the model airplane electronics and accessories, you can just get the foam wings, fuselage, tail, elevator, everything for about $60. So, if I really mess this up and I can't glue it back together anymore, then it's not a big deal. I just, go call my parents and, hey, hey guys, I need some more dough here. So, another interesting thing that you can do with these is you can fly at night. So, with that $18 board camera, like I mentioned, we have a really low lux rating, which means that we can kind of see in the dark. Mostly, you use infrared lights to kind of illuminate what a camera's looking at. But this was taken about 45 minutes, maybe an hour after the sun had gone down in northern New York. And as you can see, the horizon right there, it's all lit up. The sun is set, and I assure you, I couldn't see my fingers, 6 inches in front of my face. But all the lights on the ground, and we had a little bit of cloud cover, so it was good illumination. Now I take that back. We did not have good cloud cover, so there was, good moon illumination. And you can see that, it's almost like daytime, except you have all these bright lights. And so, question over there.
Yeah, you were talking about the lithium polymer battery earlier.
Yes.
Are you running a single power source for everything, or are you running different power sources for the electronics and for the motor?
That's a good question. Normally,
And if the former, have you run into any noise problems?
okay, so the question was, if you're using a LiPo battery, are we using a primary battery source to power everything, or are we using multiple batteries to kind of splice everything out? Because you get noise issues in the power. And the answer is it all depends on your ESC. If your electronic speed controller does a really good job of filtering out the noise from the motor, and then the regulated power that gets sent to the receiver and to the ArduPilot and everything, then you can get away with one battery. But generally how I do it is I use one battery for the payload, because the video transmitter has absolutely terrible feedback down the power source, and that would, I suspect, really mess with my microcontroller. And so just to be safe, I keep that on a totally separate battery. And then the whole autopilot system and the motor are all on its own separate system. So usually I fly with 2 batteries. One's going to be huge. It's going to be about 2,000 milliamp hours, generally is what I fly with. And then the payload battery will be anywhere from 500 to 1,000 milliamp hours, which is really small, very lightweight. depending on the mission length. So you want to do a power budget ahead of time, and really you only want to put the amount of battery power up in the air that you need for your mission, because anything extra is really just kind of a waste. You're making the plane heavier, and you're going to get worse flight performance out of it. Yes, in the back. Have I looked at solar panels? NASA looked at solar panels. NASA had a lot of money. I just don't have the money for, like satellite-grade solar panels. And it has been done. You can get model airplanes up in the air. NASA has a couple flying wings that they've set Guinness Book of World Records with. These things would just go up, and somehow they would kind of fly around and recharge batteries, and they would just fly with batteries at night. And they kept them up for days at a time. I think I looked at that in like high school. Like I shammed some high school project, by gluing some solar cells that I found in like a discount hobby place, and I told them it worked. It really doesn't. You need a lot more energy to keep this plane airborne than solar cells will provide at the moment. Yes, sir.
So for your kit, what you've got there, how much did you end up paying?
Okay, so this setup right here, the plane itself is about $60. The engine upgrade is about $50. The FMA Copilot stabilization system was about $50 to $80. The video transmitter is $50. Extra antennas, probably looking about $40. Ardu Pilot, the shield, miscellaneous servo cables, the batteries, the speed controller, you're probably looking at about another $200. So this plane right here represents about $400, $450. So that's the ground station, though, is kind of where you spend your real money, because you need a 7-channel radio or higher to have enough channels to really operate this, and it needs to be programmable. So that's going to really run you a lot of money. You're probably looking at like $500 just for the stinking video transmitter. And when you pop it open, because you're curious and you want to see what you paid for, you're really like, man, are these guys serious? Like, I could have put this together for $100. But you're probably looking at slapping down initial startup costs, I want to say about $1,000. And then after that, you're looking at maybe $500 per system. So this stuff is very inexpensive, especially if you can, get a university to kind of fund your research or something. Yes, little guy over here. Nobody spotted or reported me yesterday. Not that I've heard of. There's no Marriott representative in the hotel or in the room right now, is there? Because. Would you like to fly again before the end of the conference? Yes. Okay. We'll set something up. If the snow, it all depends on wind conditions. I kind of got paranoid because I lost a whole bunch of models. I'd take them up, as soon as I get it put together, I'd run outside, and we're in the Hudson River Valley up there in West Point, so like there's like 60-mile-an-hour winds like all day long. I swear they put this place in like the coldest part of the East Coast they could find. And so I'll put the model up there, and it immediately go like whoosh, and it's like exit scene left, and I'm like, oh man, are you serious? Like, where'd this thing go? It's like floating down the river. So if the wind conditions are right, I will definitely take it out. We'll put it up again, and hopefully we'll get a better RF link. And I can demo that. Maybe we can work something out where we can stream that video feed. But if you guys would like to come out, just ask me later. We'll set a time up. Yes, sir?
Is that ground control system you mentioned getting real-time data from the plane so you can see how much battery life is left? And
Good question. So the ground control system, I didn't put a slide up on the ground control system because, well, honestly, I haven't really gotten it working yet. But I like to look at just the serial feed live, and when the plane's up there and it's doing its thing, you really can take your time and just look at your laptop and look at the numbers. But Jordi Munoz, the 25-year-old guy that put together this $25 autopilot system, he actually built a entire setup in LabVIEW with dials and everything as if it's an airplane system. And so it shows you your orientation, airspeed, current battery level, and everything. And that's actually really cool to look at. I just haven't gotten it working because I was messing with it and I broke it. So, but the autopilot system, the ground station is pretty awesome. The picture you saw earlier was the config tool, and that's what you use to upload via umbilical cord the waypoints. So let me just finish up my last 2 slides here. ArduPilot Mega. So the community recognized that there was a fundamental deficiency with ArduPilot, and that was that there was only a single serial line in and out of this microcontroller. Because of that, and because the GPS uses that serial line, we can't pass updated waypoints or coordinates or instructions to the plane using those XBs. So the XBs kind of act as a one-way link right now, which is really unfortunate because, I mean, think of what we could do if we could, change the setup while it's up in the air. I mean, that'd be awesome. That really would be the next step. So they're coming up with an entire new board. It's going to be called ArduPilot Mega, based on the Arduino Mega. Essentially, they just pin out everything in a better order, and I believe there's going to be another microcontroller on board similar to this one, like an @tiny, and that's going to provide fail-safe operation. But with that extra serial line, or serial lines, because I think it's going to have 4, you'll be able to pass instructions to it, and it's going to have more bells and whistles. So that's the path the community is currently going in. Something I want to do personally is take an iTouch or something similar like that, build a graphical user interface or whatever that I can manipulate, similar to the config tool, so I can pan Google Maps around, drop waypoints live, and have that sent up to the UAV. So I can literally just walk around, it'll follow me, I can change its waypoint path and everything, and if I want to see what's over that hill, I just kind of flip a button and look around using my video goggles. I'm a total badass, So that'll look awesome. And easier configuration. They're really kind of working on stepping the code down right now because they have a configuration file that you change parameters, and it's very well commented, and that's all you really need to do. You don't have to touch any source. But it's still a little complicated. So there's a couple guys in the community that want to put a video out there that's kind of oriented toward the high school crowd and how they can make this. Because if you can teach a high schooler to do this, then maybe someday I can teach my mom how to do it, and that'd be cool. So, yes, sir. Yeah, about that. I got some things. I got some things to say to the Air Force guys, the Academy guys. Nothing against the services, but the Academy rivalry is pretty intense. So really quick, I just want to hit on some legal issues. The way we fly these legally is under the FAA model airplane regulations. The AMA, the Academy of Model Aeronautics, I think that's right. They publish safety rules and everything that generally you should try to follow by, but I'll just summarize for everybody's benefit here because you're never actually going to go out and look up legal issues for this. To be legal, technically, you have to fly under 400 feet within line of sight and have the ability to take control of the plane for safety purposes. 400 feet up. Now, you can take it out as far as you can see it, and let's be honest here. This plane will go up as high as you want, and with a video setup, you don't even have to see it anymore. So as long as you have a solid RF link and you can take safe control of it and bring it back to you manually, which means that you have to have some proficiency flying a model airplane, then in my book, you're good. So just, that's how I roll. Fortunately, there's no FAA guys out there. Are there? If there are,
Same guy who thinks the tree is a landing mechanism.
It works. Okay? It works. The plane is right here. This plane literally ran into a tree yesterday, and there's nothing wrong with it, right? So it's not flying right now. We'll fly it later, I promise. But another thing with RF issues, I really encourage you guys to go out and get your ham radio license because with that opens up all kinds of band privileges, and you really get all the knowledge necessary to work some of these more advanced systems. You can pair and match antennas better if you have this education. It only costs like $14 or $12 to go get your license, and when you sit, you can test up as many classes as you like. So that's a great community. They provide a lot of support to me because I still don't know how to pick antennas. I just find some old guy who, oh yeah, this antenna here, this here, that's what you want. And finally, legal issues. Like I said, it's not stalking if it's love, guys. So questions, let's break it out. Yes, you speak up. So I like to do everything from soup to nuts. Okay, so he was asking if anything's being done on the observation side, or what was the rest of it?
Basically, could you say if we follow that
Oh, okay. I don't, so a problem with this airframe is that it has a limited capability to carry weight, which means that our processing power is very low. We're just using at-mega microcontrollers here, so we don't have onboard capability to do image processing and follow targets natively. That would be a really cool thing if somebody could do that on a gum stick and kind of throw it in there. You could stick a smartphone on it. I've seen that done in the community. If you want to write that yourself and give it to me, that'd be awesome. Maybe I can come back next year. So, yes.
Hey, since, if I remember correctly, West Point's a non-fly zone for non-military aircraft, so how does that affect your model airplane flying?
Okay, so here's how I do it at West Point, because I'm not allowed to. Where you saw me flying, I'm really not supposed to be. I kind of look around. Are there any officers? We step out, and then step back in. That's how you do it. In the back.
You configure that if it loses good RF signal, it's automatically just to return to launch?
Can you configure it to, if it loses an RF signal, to automatically go back to RTL? In certain versions of the code, that's actually default behavior, and you could definitely code it that way. Essentially, with the current software version, I believe how it works is it's just going to fly its route independently of the RF signal. But if it loses the command from your transmitter that's telling it to stay in autopilot mode, then it'll flip out, and not like flip out like go all berserk, but it'll come out of that mode and it'll go back to RTL and just kind of it just kind of orbits overhead in like some random fashion because it's trying to hit your GPS coordinate, but it will come back to you. Or it should. It should. Any other questions? In the back.
Yeah, I've got a request for those playing at home. If you're playing and somehow you can patch it into streaming to Shmoocon site.
Okay.
Appreciate it.
Yeah, we should figure that out. That'd be.
And I don't know if you saw the iPhone patch this morning, but if you could tie that into, following people on their iPhone.
Oh, hey guys, one other thing I forgot to mention. Some of the other payloads that you can throw on here that we actually have are a Bluetooth sniffing payload, or maybe it's a Bluetooth pushing payload. Major Terrence O'Connor, he's coming up to talk in 2 hours. He actually wrote that for me. We just kind of threw it on here. So we could you're walking around with your little Bluetooth thing in your ear and suddenly you hear something different. Yeah, we did that. And war driving, there's been examples of war driving done before, but now you can do it with an autonomous aircraft, so that's kind of cool. And we're working on figuring out the RF to actually do consistent 802.11 sniffing from the air. So now you don't even have to get off your ass to go figure out what those guys are doing a couple blocks over. You can just send the plane up and it'll orbit overhead, and you can check out what he's watching on YouTube if he's. Yes.
Are there helicopter-based aircraft that can handle the kind of payloads that you're...
Helicopter-based airframes. Helicopters are very difficult, because of their inherent instability and also all the forces that are being imparted on it. They have a lot of vibration that really messes with the sensors. There are a lot of attempts out there, especially with the UAV dev board, throwing that on helicopters. I haven't seen amazing success with it, but I mean, they can get a helicopter to kind of hover and everything, but it doesn't work so well outdoors when you have wind. As you saw, my airplane was pitching around and it has great stabilization. I don't think you can take a helicopter out there and ask it to fly around a couple miles and come back in one piece. It'll probably find its way to the ground.
I'd like to ask about the helicopters. I don't know if anybody is doing this work, but I've dealt with a lot of helicopter stuff. They're temperamental, they're hard to fly, getting them down is difficult, and they're really expensive. So it's not a platform I would want to pursue unless I had really big backing.
So there you go. Helicopters are not a good idea. All right, ladies and gentlemen, I'm done. If anybody what? I hope you all enjoyed the talk, and we will see if we can hook something up and fly the plane later today or tomorrow. So stay tuned.